So I think I'm live. It's 8 a.m. in Manchester. Welcome. I'm guessing you can hear me. Please send me a message to make sure you can, to tell me that you can hear me. Can you hear me okay? Thank you very much. Thanks, Fred, and thanks everybody for joining. This is amazing. I'm quite excited. I'm quite terrified as well. I don't know why I should be terrified, but there we go. I am a little bit. It's quite exciting. So again, thanks for joining. So we're going to do this every Friday, same time, obviously, because it's easier to remember. And yeah, I've got my setup here. I've got my water. I've got my coffee in my amazing SAP Coffee Corner Radio podcast cup or mug. So I've got my coffee ready here. I've got my microphone, which you can sort of see here in the video. I'm not quite sure. Maybe I'll get a different angle for it. I've got a little hack as well to stop the springs on the arm from pinging all the time when I type. I've got my keyboard and everything. The keyboard's a little loud. It's got Cherry MX Blues. I've ordered another keyboard actually, just a good excuse to be a bit quieter. Yeah, we're gonna get going now. So I've got this scene here with my video, and we've got the chat here as well. But I'm going to move now to my main, sort of the main scene, which is actually this screen right here. So you should be able to see me, you should be able to see the chat, and you should be able to see my left-hand monitor. So just a bit of housekeeping. We're just going to do this once, this very first time. We've got a schedule there, and you've got links as well and about me and everything. But I guess maybe most importantly is, all the people I can see in the chat. You know, you're all awesome folks and everything. And I know that I don't need to tell you this, but let's just do this anyway, because yes, it's going to be recorded, and you'll be able to see these VODs, video on demand. That's apparently what you call them in Twitch and in these live streaming sort of scenarios. So basically, you know, all the common sense rules apply. We've also got, in the SAP community, we've got this sort of rules of engagement here with participation etiquette. You know, again, it's common sense. Be polite and friendly to each other. We're basically here to learn with each other and from each other. So yeah, basically be nice to each other and be gentle with me, because as usual, I've no idea what I'm doing, but I thought I'd give it a go and see. Okay, without further ado, let's jump in. We're going to do this for an hour, so if there's any questions as well, please just type them in the chat. I've got the chat over here on my right-hand monitor, and I can see it quite well. So if there's any questions you have throughout, you know, just dive in. There's all sorts of things you can do on Twitch with bots and so on, and commands that can be repeated and everything. But oh, thank you, Frank. Yes, we can. Very loud there in the capitals. But I've not done that yet, so I'm just starting out on this sort of whole journey with you folks. Maybe if you're interested, one particular episode, I can go through my setup, I can go through my physical hardware setup, I can go through the setup I've done for streaming to Twitch and so on, and the things I'm using, like for example here, I'm using Streamlabs and all sorts of different things here, and you know, it's a pretty good set of tools that I have at my disposal, or anybody has at their disposal for doing this sort of thing. So the general idea is that I'm going to do this weekly on Fridays at 8 a.m. in Manchester time, and we're going to talk about SAP dev topics. So a backbone topic that I'm going to start out with over the next few weeks is the cloud application programming model, which probably doesn't surprise some of you, specifically the Node.js flavor. Of course, you know, there's a Java flavor as well, but I'm going to stick with the Node.js flavor. Tell you what, it's really odd sort of looking into a camera. You know, obviously I've spoken at conferences and everything and speaking to people on stage, but I'm just speaking to this plastic thing here, which is just a little bit odd. So I'll get used to it, I guess. I've got my stream health here. Anyway, we're going to use that as a backbone of stuff to talk about and stuff to hack on. But because I'm trying to think of about a million things at once right now, I thought I'd start out quite easy for us all and get our brains warmed up. So if we have a look at the at our tutorial Navigator on developers.sap.com, you can find that yourself, I'm sure. There's a ton of tutorials and missions and groups and so on, and we've got a relatively new tutorial from this month, actually, from a colleague of mine, Andre Foreman. He's written a Node.js flavored version of some tutorials we already had on the cloud application programming model. We're not going to go through this tutorial specifically right now. We probably will end up doing that at a later stage and then digressing and so on, and so going off-piste, as it were. It is sort of ski season after all. But the reason I brought this particular tutorial up is because if you have a look through this, and rather than scroll down, I'm just going to jump straight to one of the steps here. VS Code, yes. We're going to be using VS Code. I'm going to be using VS Code in this series, but actually today, because it's the first one and because it's still my favorite editor, I'm going to be using Vim and tmux and so on, just because. One of the things I wrote in one of my Monday morning thoughts posts that some may have read is that, I wanted to renew my my foo in all things Vim and plugins and so on. So I've been trying to do that, and so I've got some plugins I've been using, some awesome plugins. I've ripped my Vim RC apart and started again. So if you're interested, we can have a session on that as well at a later stage. Anyway, I'm going to jump to this initial stage. By the way, is this the resolution? Oh, you wouldn't believe the stuff I had to look into for streaming resolution and bit rates and so on. But just shout if the resolution of the text on this screen right now is too small. I'm going to assume it's okay for now. I think it's okay. I'm going to jump to this add initial data here. Where are we? Here we go. Yeah, okay. No, actually not add initial data. Provide mock data. I'm going to jump straight ahead because one of the things, if you read through this tutorial, which is a really good tutorial, you'll come across all sorts of features of the cloud application programming model, one of which is, you can very easily mock data by, writing some code that spits out or that provides data. And, if you're running past this, when did I run this morning? There's a link for you. If you run past this at a high speed and just glance at it, you wouldn't recognize this necessarily as JavaScript. But it is. And some of the folks working on the cloud application programming model team in Waldorf and elsewhere, this is sort of this comes from them, and they're very sort of what's the word I'm looking for? They're very well up on ES6, ECMAScript 6, which is the 2015 version of JavaScript, which sounds out of date, but actually it's still for many of us quite new. So this, there may be some constructs here that look a little bit odd. So what we're going to do, and there's another example here. If we look at the custom logic step, there's some other stuff here. We got some odd curly braces here. That's destructuring. We've got the fat arrow syntax for function definitions and so on. We've got all sorts of really, really juicy ES6 aspects of JavaScript. And of course, also what we're not seeing here is semicolons. It's very trendy not to have semicolons these days. So I'm trying to not use semicolons in JavaScript. Anyway, so rather than dive straight into the application programming model, I thought we'd warm ourselves up with a little bit of ES6 JavaScript, and what better to do that by maybe solving some problems. Might be too small for screen, smaller than 19 inch. I think. Okay, so what I'll do. Hey, hi Patricia. And by the way, thank you all for joining and coming along. That's awesome. Oh my goodness, we've got 55 viewers here. This is incredible and scary. So. I'll just make this a little bit bigger, but actually we're going to move away from the browser and spend most of our time in the terminal. So I'm going to make this font a little bit bigger. I think we can afford to make this font quite big. But before we move into the terminal, actually, let's bring up a puzzle. Now, this puzzle, I've done this puzzle before, and I know that it's sort of a nice and interesting one for us to do. There's 2 parts to it. We're going to read through it very slowly. Hold on, somebody said my screen is smaller. My screen is smaller. Miles, your screen is huge. I've seen it. But yeah, okay, resolution rather than size. Much better. Thank you very much. Okay. And thank you, Strotlog, for confirming 17 inches okay. 17 inch, amazing. Yes, I have a 17 inch somewhere. So yeah, this is a puzzle in 2 parts. It's very straightforward. So I think it's a good thing for us to start with, especially because, of course, maybe many of you haven't seen this puzzle. So let's just close that one. That was just to log what's going on here. So yeah, let's just dive straight in. This is Advent of Code. It comes out every year. I'm not going to talk about Advent of Code too much, but it's an amazing sort of annual thing that happens. I've done some puzzles, not all of the puzzles, the past few years, and it's sort of Santa Christmassy themed and Santa's helpers and everything. But anyway, the key thing is, I'm going to highlight it here. This is the first thing we're going to solve. And then we're going to solve part 1, and then we're going to solve. Oh, there's a cat there. But then we're going to solve part 2. By the way, I've got the blinds open. It's just coming light here, and I like the windows or the blinds open. So if a postman comes or the milkman or somebody, I'm going to have to get up because this is live and everything. But anyway, let's solve this. So we've got. Let's just dive straight in. Below the message, the device shows a sequence of changes in frequency. Your puzzle input. A value like +6 means the current frequency increases by 6. A value like -3 means the current frequency decreases by 3. And you start with a frequency of 0. This sounds more complicated than it is right now. For example, if the device displays frequency changes of, and we're going to copy these, +1, -2, +3, and then +1. I'm going to copy those right now. Then starting from a frequency of 0, the following changes would occur. Current frequency 0 +1, it's now 1. So you're 1. Then you get -2, so you're -1. And then you get a -1, so -1 and -1, and then you get +3. Then it's 2 again, then it's 2. And then you get a currency frequency change of +1. So 2 + 1 is 3. So the resulting frequency after going through all these different changes, starting from 0, +1, -2, +3, +1 is 3. Okay, so, and the general idea, if you haven't seen Advent of Code, is that you get this sort of description and you get this sort of example input and the expected output. So you get the input of +1, -2, +3, +1 here. You get the expected output of 3. So starting with a frequency of 0, what is the resulting frequency after all of the changes in frequency have been applied? Okay, so I've done this before. The answer is 406, so that's what we're looking for. But we're going to go through this again from scratch with some new code. At the bottom here, you get your puzzle input, and everybody's puzzle input is different, by the way. And the puzzle input, I'm going to click on that, and it looks like this. And you get all you get 1,000. I think it's 1,000, maybe 1,000 plus different frequency changes. So we're going to have to grab this shortly, but we'll start out by that's big now. We'll start out by just grabbing, or we have already grabbed, the example puzzle input. So I guess the question is, how are we going to do this? How are we going to have a development setup with a quick turnaround of results, so we get an immediate feedback and so on. So I'm going to start out. So let's go into my projects folder and make the episode 0. There we go. So what I'll do is just initialize this as a new npm repo with using JavaScript and everything, and using Node. This is obviously server-side JavaScript. One of the really cool things about the cloud platform, and especially Cloud Foundry, is that JavaScript is a first-class language for us, not only on the front end with UI5 and other front-end frameworks, but also on the back end. It's really nice. By the way, the chat's gone quiet. I'm guessing you're still okay. Christian, finally I'm going to learn some JavaScript and NJS. Is that ninjas or something? That's quite exciting. So package name, blah, 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 blah. Okay, so there we go. This is okay. Yes. The reason I've done this is because I'm trying to, follow good practice, but also we're going to install, I intend to install an NPM package that will help us sort of monitor and rerun things when I change stuff. I've got one thing already set up, so you're not looking at me typing a ton of stuff, but we're going to actually write the solutions together live. Okay, so I've got a package JSON, which looks like that. Now, is that big enough? I think it's big enough. I'm going to move this, what's it called? This microphone down a bit so I can see the screen. There we go. But we've also got an index.js. So if you look at the package.json, by default, it will, if you run this package, it will run index.js, which is what we want. So I've got an index.js. Why don't we? There we go. So we've got an index.js, and this is almost like my test harness. I've created this deliberately in advance, so we can use this test harness to test the code that we're going to be writing. I'm just going to go through this now. So the first thing is, and by the way, again, I can go through. I'm hoping somebody wants me to go through this sort of setup because I'm quite excited about it. I'm using the Dracula theme in Vim. I'm using, for example, relative numbering. I've got all sorts of plugins like the surround plugin, and I've also got Goyo, for example, which is really nice for writing non-code and everything. It's okay, cool. It's readable. Thank you very much. Here we go. So the idea is that the advent of code is a puzzle or two puzzles every day. Part 1 and part 2, or part A and part B. So I've got this idea that I'm going to create the solutions to puzzles in a file called day something, day1.js, day2.js. And the input, the stuff that we're going to have to sort of grab, which is this input here, we'll have in a file called day1.input, for example, okay, and day2.input, and so on. So really simple. I'm going to keep them in the same folder, same directory and everything. I've got a little function here that will just do a generic cleanup of the input. Now, some of the input I've noticed, sometimes there's some blank lines, there's some sort of new lines that we want to replace. So all I'm going to do, and of course the input we want in an, well, no, we don't necessarily want, but it's nice to have the input as an array. So what this does, if you look at the input here, it's in a series of separate lines here, +7, -5, and -9 and everything. So what this clean function does is take the input, which is a big lump of stuff, and we're going to split that big string, this whole thing all the way to the bottom will be the string. We're going to split that on a new line. Okay, so that splits already into individual items in an array. A split creates an array. Okay, so and then we're going to map over each of those items in the array, and we're going to take each of the items and we're going to replace any sort of carriage returns at the end. Okay, this is a regular expression, carriage return at the end of the line with nothing. And also we're going to filter out any lines that are empty. Okay, so basically this is, I want to filter and only have lines, only have items where the item.length is a truthy value, as in not 0, because 0 is not truthy. Okay, so in fact I've even got comments there. Look at that, it's amazing. Split lines into array, remove any carriage returns, drop any empty lines, and so on. I keep seeing myself over here, it's distracting, so I'll move it over there. In fact, I'll make that full screen on this screen here. There we go, perfect. How are we doing for time? Okay, perfect. Then the other part of the solver is loading in basically this day1.js here. So down here we've got this require statement, and if we look at the basic solver in a minute, you'll see what I mean. In fact, why don't we day0.js, a solver is going to look like that. Okay, so we've got a solver with two functions, a function A and a function B. And at the moment, these functions don't take any input and just produce hello for A and world for B and so on. And then we export those functions. And that's sort of a really basic way of doing sort of modular JavaScript coding. Okay, so I'm going to go back over here. Okay, so what we do then is we load the input. So we read the file input, which is there. Okay, so this is the day1.input, and we read it in using the fs module, okay? And you know, most of the modules in npm, as in most of the modules in Node rather, are asynchronous. So of course we supply a callback function that then gets executed when that read file function is finished. And that callback function gets any errors if there are errors, and gets the data as well. It gets given the data, which is the +7, -5, etc., etc. So the first thing we do is we clean the data, and then we just call solve.a, which is the a function over here, passing it the input values, and then we call solve.b, and we write it onto the console. Okay, so what we'll do actually is we'll edit a input one, day1.input, day1.input, and we'll have, I think it's still in my paste buffer, isn't it? There we go, perfect there. So we've got the test input. We'll go back here actually, yeah, I get a bit bigger again. We've got the test input +1, -2, +3, and +1. And of course we want to split those into separate lines, so we'll replace the comma and the space with carriage return, all of them, there we go. So we got our test input there. Okay, so what we'll do now is we'll run it. We'll run the index, okay, because, let's just do that, let's get out of that. Node index.js. So first of all, we can't find module day1. We haven't got a day1.js, so we'll copy AOC, advent of code, day0.js to day1.js. And in fact, what we'll do, we'll use tmux, and we'll go into day1.js there, and we'll also have another window where we can run node index.js. Okay, and we get hello world, which is amazing, which is, you know, not unexpected. Okay, so we're sort of set up to do some development now. Okay, why is this modular? Because then I can, that's a good question actually, because then I can use the test runner, which is this one here. Where are we? Oops. I can use this test runner to run it for any day. That's the reason I'm doing that. So let's just go here, and we've got now, if we change this to banana, for example, I've got to go over here. Oops, there we go, and run it again, which is no good. So what I've thought is there's this thing called nodemon. GitHub, monitor for any changes in your node.js, and automatically, here we go, it's a tool that helps develop Node.js applications by automatically restarting the Node application when file changes in the directory are detected. So have a look at nodemon, you know, after this live stream. I'm going to install it, and it's just an npm install nodemon. And because it's not not anything I'll need if I were to deploy this and run it sort of for real in production, there's a thing in npm called in fact, let's have a look. Packages in here. There's if you install a package, it will go into a dependencies section, and those are sort of dependencies for runtime. But actually, this nodemon is a dependency only for while we're developing, and this is a special dependencies section in packages. So we say npm install nodemon, and we say save dev. That will install nodemon, but save it into a development time only specific set of dependencies in the package.json. So let's have a look at that. While that's happening over here, let's change this back to hello, for example. In fact, it's just finished there. So let's have a look at package. Oops, package JSON. There we go. We can see in dev dependencies we've now got nodemon, which is quite exciting. So now let's go back to over here, and we can say npm node modules. Let's clear the screen. Node modules. Nodemon, nodemon, and bin nodemon .js. Is that a thing? Yes, there we go. Okay, so what it's done is it's automatically running the index.js. And if I go now to day1.js, and save that, it will run it again. Okay, so that's exactly what we want. In fact, I want to just swap these screens around, or these panes in tmux, so I'm going to see it a little better over here. Are we all still okay? So yeah, I hope we're okay. Yeah, this is good. This is good chat. Oh my goodness, 58 viewers. What is going on? This is amazing. Thank you very much for joining, everybody, and also for following. That's really good. We keep seeing. Oh, you probably see it. I don't. So I've just seen that. Somebody else. Oh, my goodness! Here, Vladimir has just followed, and Mark. I just saw Mark has just followed as well. It's amazing. Thank you very much. So yeah, we've got this file here. We can start sort of doing some actual work now. So also remember that we've got our day one input down here. Let's make this a bit smaller. There we go. Okay, so fine. So the thing is, what we've got to do on this, let's just remind ourselves of the challenge here. Basically, we've got to go through these frequencies, starting at 0, these changes, and work out what it is. So start at 0, add 1, minus 2, add 3, plus 1. Of course, we can do this in a, an old-fashioned sort of, for loop way. But rather than go through, well, actually, maybe we should do that. I'm not sure. Yeah, actually, well, yeah. Let's split this first of all. And make it into a sort of a slightly larger function block. So in ES6, this is called a fat arrow syntax. This is just a way of defining a function. And these are the function arguments here. And if you've got no arguments, you still have to put some parentheses as almost like a placeholder. But we're going to have arguments here. We're getting past, if we have a look at the test runner, we're getting past the input here. Okay, so we're going to expect the input here. In fact, why don't we call it, so we know what we're talking about, the changes. Okay, so first of all, why don't we return just to see what's happening? Okay, return changes. One nice thing again, there was a question about this whole modularity thing. One nice thing again about this sort of test runner thing and automatic rerunning and the fact that I'm writing in this module is that rather than write out console.log and try and maybe do some sort of test development in the Chrome developer tools, for example, which is where I quite like doing that sort of thing, I can sort of return the wrong answer. It's just me checking it over here, and I can see what it is. So let's return changes and see what that looks like first of all. So let's just save that. In fact, if I go here, in fact, let's have another terminal session for a second. CFV. I've got all sorts of shortcuts here. You can look at my Vim RC file, and I've got. I've mapped a leader key to comma W, so I don't have to do colon W, because I don't know, it's just slightly hard on my fingers. Anyway, let's go back to this tmux here. So if I do leader W, it saves, and we run. It gets run, and we can see what the solver function A is receiving. Okay, so it's receiving a nice array because we've done this sort of cleanup of +1, -2, +3, +1. So why don't we, put our heads down and just go for it and try something? I'm going to there's something I've noticed here, but I'm not going to sort of point it out yet. Instead of return changes, what we can do is we can say, well, actually, yeah, why don't we have here some var, let's do it old-fashioned ways first. Var frequency equals 0. Let's start at 0. For var I equals 0, while I is less than changes.length I plus. I'm intrigued to know how loud this keyboard. I love it, but my wife Michelle hates it when she's in the room. But I don't know how loud it is coming through on this microphone here. Well, actually, Fred, you're right. I'm not going to use the word fold, although I just did. But yeah, I mean, I'm going to use the fold in the form of reduce. Let's come to that shortly. Gentle start. I've still got some coffee, so once we're out of coffee, we'll do a fold. By the way, if you've not subscribed to the SAP Coffee Corner podcast, you should do, because it's amazing. I'm going to drink some more coffee. By the way, keyboard is noticeable but quiet. Okay, thanks, Strotlog. I don't know who Strotlog is, but thank you, Strotlog. Maybe I should know. Anyway, reduce, okay. Okay, reduce is okay. Yes, thank you, Fred. We're going to use reduce. So we're going to say frequency equals frequency plus changes of I. Okay, that's all pretty straightforward, and we see this everywhere. Okay, and then we're going to return frequency. So I'm going to try that. But look what we've got over here. We've got 0 plus 1 minus 2 plus 3 plus 1. You know, one of the things I love about JavaScript is it's always a very literal. It's a little bit like Perl in that, you know, it's sort of, you know, untyped and everything. Well, not untyped, sorry, you know, dynamically typed and quite loose and everything. So yeah, it's just done exactly what we've asked it to, which is to add or concatenate these things together. These are strings. So what we need to do, of course, is turn them into numbers. And in JavaScript, there's a number class. So we can say, for example, number, force that into a number. Okay, let's just save that. And then we get 3. Okay, so that's better. Okay, so we get 3, and 3 is what we're looking for. Okay, but we can do this at a nice, good morning. We can do this a nice way. Oh yes, Christian's pointed on the chat to my Vim RC files. I can do a session on all of my. I've been trying to sort of publicize all my configuration for Vim, for Ranger, all sorts of stuff. There's a chap I'm following on YouTube called Luke Smith, who does some amazing stuff that I've been learning from recently. I definitely recommend you look at Luke's stuff. But yeah, I've got a .vim repo. I've got a scripts repo as well. The topic today is just a little bit of ES6 JavaScript, getting ourselves warmed up so that when we move into the next Friday's episode and looking specifically at the application programming model, node flavor, you know, we're hitting the ground running. But today, yeah, we're solving a puzzle from Advent of Code. Thanks, Fred. Advent of Code. Thank you, Fred. So we're going to get rid of all this because we don't need it. What we're going to do is we're going to sort of embrace a little bit of standard JavaScript. This is nothing new, but we're going to embrace a modicum of functional programming. And in fact, why don't we just go for broke and do it all on one line. So first of all, we're going to map, which is, of course, you know, it iterates over the items in this array and then calls a function for each one. And because number is a function already waiting for a single input, effectively, we can just do that. So we'll do that to see what it gives us first of all. We'll just save that, and we get now numeric versions of the data that's already up here. So we're already winning. Okay, let's go back here. Oops, let's go back here. One of the other nice things about NodeMon is that I don't have to switch panes in tmux and remember to switch back again to carry on editing. So now I'm going to, in fact, why don't I make this a little bit bigger. Let's just go, there we go. Yeah, that's better. I learned that only yesterday in tmux. It's the leader key, Control A in my case, and then capital H for left and capital L for right. You can sort of, and they're repeatable, so you can sort of bong, 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 make them bigger or smaller, which is quite nice. You can also sort of, do Control A and space to iterate through various pre-configured pane layouts and everything. But this is good enough for me. So what we're going to do now is we're going to use the reduce, which is a little bit like fold, as Fred mentioned here. And reduce is another function that iterates over a list of things, iterates over an array. But the reduce function, instead of taking one value, it takes two. It takes an accumulator, and then it takes the thing, that each item time after time. And what we're going to do, all we're going to need to do here is for each time round, we get the next item in X, as in we're going to get 1 first of all, then -2, then 3, then 1, and everything. Are those the right values? 1, -1, 2, 3. Yes. 1, -2, 3, 1. Yes, that's correct. Yes. Okay, good. But all we need to do, oh, by the way, before we put what's in this function here, Reduce itself also takes 2 parameters. And the second parameter is the starting value for reduce, for the accumulator. Now that starting value doesn't have to be a scalar, it can be anything. So in this case, but in this case we are going to have a scalar, which is like the starting value of 0. Okay, so we're going to do that, and all we need to do is a plus x. Now in this very short form of a fat arrow function definition syntax, you don't need any curly braces and you don't need the return statement. So whatever the evaluated expression comes to, that's the thing that's returned. So that actually should give us what we want. So let's just save that. And we get 3, which is sort of right. So what we'll do is we'll go to our input. Let's Command A, copy all that. And then now what we'll do is we'll go down here. We don't need this anyway. Let's go to this one and paste this in. In fact, pb paste. Yes, we get that pb paste into what's it called? day1.input. Okay, so in here, yeah, there we got it there. We got the 1014 lines of input. So now what we'll do is we'll go up here and we'll save it and we'll see what happens. 406. Now I think that was the right value, right? So 406, let's go here and your puzzle answer was 406, which is correct. Great, okay, so that's good. You know, we've got a little bit of a warm-up. We'll do the second part, though, because that was quite easy. We'll do the second part of this day 1 puzzle, which is a little bit more difficult. It's each day on the advent of code. Again, this series is not about the advent of code, but I find it really useful for sort of warming my brain up. Oh, yes, thanks, Christine, for answering. Yes, the idea is that these streams should be automatically saved. I found the switch on Twitch last night to turn it on, automatically saved and archived as watchable videos. They're called VODs, video on demand, I guess. But I'm also in my streaming software, which is OBS, online broadcasting system or service or something. Really good, but quite complicated for me. I'm also recording it onto my hard drive, so just in case, so I can upload it if we need to. So that's part 1 of this day 1 solve, but we'll solve part 2 because it's a little bit more interesting. It allows us to think a little bit more about another aspect of JavaScript that will probably come in handy when we're doing stuff with the application programming model in the Node.js flavor, which is the concept of a closure. I don't mean closure with a J. I don't mean the language closure. I mean the concept of a closure. By the way, let me know again if I'm. This broadcast is going to be an hour. The whole idea is each broadcast is an hour every Friday, same time, same place here, and so we got another 22 minutes to go. Okay, so okay. Thanks, Christian. Good luck. Yes, force everyone to watch it. Brilliant. So we'll do the second part. So the second part still has the same input. So in fact, it's even got the same test input. So we'll use the same test input shortly. But the second part, let's just make this a little bit bigger again. Using the same list of changes above, you need to find the first frequency it reaches twice. So the frequency starts at 0, and then it changes to whatever, goes to 1, and then it gets to -2 and goes to -1, and then it gets to +3 and goes to 2 and everything, etc., etc. And then it will wrap round and start at the frequency change list again. Okay, wrap round, bit of a clue there. This is modular arithmetic in terms of the index and everything. Yeah, exactly. I need to figure out what's happening with VODs on Twitch. I could maybe also put them on the SAP developers channel on YouTube. That's another idea I've got as well. But anyway, yes. So what we've got to do is find the frequency that we've seen before. So at this point, the device continues from the start of the list So we start a list, we get 3, we start at +1 again, we get 4, and then we get 4, we get -2, we get frequency 2. And we've seen frequency 2 already. So that's the answer. So basically, as we go through the list, changing the frequency, what is stop at the first frequency we've already had, and then that frequency is the answer. Okay. Bearing in mind, we've got 1014 different frequency changes, but that doesn't mean to say that, you know, within 1014 changes we'll find a repeated one. Actually, it will repeat and repeat and repeat and go through all these different changes, okay, multiple times. So let's start. We've got the same input as before, the same test input, which is +1, -2, +3, +1. And this sample here, resulting frequency 2, which has already been seen. So this part 2, the example answer for the example input is 2. Okay, so that's what we're looking for. So let's just go back here. Oh, there's another follower. I can't see exactly who that was, but thank you very much for following. That's amazing. So let's start. So we've got this B here. And as we can see at the moment, it's just spitting out world. So we're going to do the same sort of thing here. We obviously changes. Now, you know, I've used the word changes as the parameter name because, you know, we know what we're talking about. But I like, and maybe a few of you out there might be the same. I suspect Fred, for example, might be one. Anybody who's watched Eric Meyer's videos, amazing guy on YouTube, on functional programming in Haskell and everything, X's. That basically, to me, my brain represents, it's just a list of things. It's not just one thing, one X, it's some X's, some things, okay? Yeah, okay, hardware, software startup, excellent. Yes, thank you very much. That's a good idea. Thank you for asking. I've been waiting for somebody to ask that. So we've got XS or X's. X over X's is a phrase that I love from Eric Meyer. So anyway, we're going to do that, and it's the same sort of thing. We're going to do a function, but this time we need to do a little bit more. So we might as well start out with a block, okay? And we'll start. So we'll also say const changes equals x's.map number. So we've got changes now, and they're all sort of, you know, they're in numeric format. If we see here, in fact, we need to sort of let's put that back in there. In fact, I've still got it in my somewhere. Oh no, I haven't. Oh well. Change comma space to new line, all of them. There we go. So we're back to the test input there, and let's make that a little bit bigger. Oops. What are we doing? Oh yeah, sorry. I'm getting so excited. I think I'm going too fast for my brain's going too fast, or my brain's going too slow, or something. My fingers are not working properly. I'm also trying to type quieter, which is a bit weird. But anyway, so we've got the changes here now. So if I, in fact, if I say return changes, we can see here, okay, there we go. We got 1, -2, 3, 1. So we're back to sort of where we started from. But now we're going to also need a way of remembering things and knowing whether we've seen things before. And, you know, in other languages, we might do this. We might create a class for this and have some sort of static methods and so on and all that sort of stuff. But JavaScript is a little bit, you know, yes, you can have classes in JavaScript and everything, but the wonderful thing about JavaScript is that, you know, you don't have to do it that way. You know, it's functional. So the keyword is function. So I'm going to create a function and use the concept of the fact that JavaScript supports closures, which is where you have a block and you've got a variable defined in the block and you close over that variable. So when you exit that block that you've referenced a variable in, that the reference is remembered and that variable is closed over and remembered. Thank you, Pred. Yes, perfect naming. So I'll just write it out and we'll explain as we go. Yeah, a quarter of an hour is perfect. So what we'll do is we'll say const, because we want to have this thing. Well, actually, let's create a block first of all. Let's get rid of this thing here. We'll create the block in the form of an anonymous function, a lambda here, and in this block we'll have a variable called values, which is going to be an array. and it starts out empty. And we're going to be putting things in this array. And one of the interesting things randomly about, as an aside, about const in JavaScript is that const obviously means constant, which means the values don't change. But that really, in my mind, only applies for scalars. Okay, so if you say const pi equals 3.14, you can't then go and change pi to 3.00. First of all, it's not allowed in JavaScript, and secondly, the world would go crazy. But in terms of the insides of this particular array here, you can change the insides. You just can't change values from being that array. So we're gonna have this as our sort of memory, okay? And we're going to close over this values variable. But then we're going to return a function. And that function takes a value, okay? And we're going to say, some water here, sorry. We're going to return a function from this anonymous function here, which in fact we'll name it now const seen equals have I seen, okay? And when you call this seen function, we will what are we trying to do? Yeah, we'll get this function called, and we're going to pass it this variable. So we return x, return a function that takes x, and say if values.index of x is greater than -1, as in if we've got that x value in our values, then we return true. We've seen it, okay? Otherwise, we want to put x values.push x, put it into values, push it into values, and then return false. Okay, so let's have this coffee here. So this is a little function now. We'll try it out. Okay, we'll try it out quite nicely. There's the end of that function here, and there's the end of that function block here. But what we want to do really is call this. In fact, I've already put the end of block there. We'll wrap this because we want to actually evaluate the call to this lambda function so that we can wrap that values array and have then the function, which is this function here, having this memory. It's almost like, having like an instance of some data that is remembered. So what we'll do is we'll wrap this over, in fact, over here, I can use the percent to find which one it is, wrap this, and then call it. Okay, so that looks really weird. I mean, obviously, you can watch this on demand again, and if you need any more explanation, maybe I can write a blog post about it. There's all sorts of stuff online as well. So what does that give us? Okay, well, let's just do something. If we say, for example, why don't we do this? 1, 2, 3, 2, 4. In fact, we can do that, can't we? Okay. We can try and go through 1. Have we seen 1? Have we seen 2? Have we seen 3? Have we seen 2? Oh, yes, we've seen 2. Have we seen 4? So I'm hoping that if I've done this right, that we should, yes, it's an IIFE, exactly, immediately, etc. Yes, thank you very much indeed. So I'm hoping if we run this, oh, there we go, 1, 2, 3, 4, what are we doing here? Return, let's just make sure everything is okay. Yeah, 42. Okay, 1, 2, 3. There we go, 2, 3, 4. Yeah, of course. We want, let's drop this. Let's try this. X, scene, X. There we go, false, false, false. There we go. And so we'll have 2, 2, 1. So we should see false, 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 because we haven't seen those. Yes, scene definition, I have no parameter. Exactly, thank you. So then we should get a true for that one and a true for that one. So let's just save that. False, 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 true, true. So we can also there we go. So we can see the values as they build up, as each call to scene is made here. In fact, there's something bugging me about this thing here. There we go. Yes, it should work. Yeah, I don't know what I did before. I probably had a typo or something. But yeah, because scene takes a single parameter, because scene is actually what this returns, which is scene is this function here. Okay, so ignore that obviously. Scene is that function. So we can actually call that just beautifully like that. Anyway, we've got now something that will allow us to work out whether we've seen something or not. So I've forgotten what we're doing actually. Oh yes, have we seen this before? So we can actually now start. Now we want some actual variables rather than constants. So we use let, which is a sort of block scoped new way of doing var effectively. There's a little bit more to it than that, but that's more or less it. We'll start out with a frequency of 0, but we'll also start out with an index of 0 to index into the changes. And we can say while not seen, well, we haven't seen that frequency, okay? What do we want to do? We want to add frequency plus equals changes of I. Okay, so we want to apply that change as we're going through to the frequency, okay? But then we also need to increment I, but we need to be careful because, of course, as it says here, the device might need to repeat its list of frequency changes many times before a duplicate frequency is found. So, of course, we've got to modulo the whole thing because, of course, if I gets to 1014, which is the number of, well, in fact, in this case, if I gets to more than 4, then, of course, it's going to go and index beyond the actual current range of the array. So we would need to say I equals I plus 1, but modulo the changes dot length. I think that's right, isn't it? Changes dot length. Changes is what we've got here, and then return frequency. I think that should be right. Let's try it. Yes, in fact, let's get rid of the console log. Let's go up there, delete that. Yeah, okay, so we got the answer 2. So is the answer 2? The answer was 2, wasn't it? Yes, 2. Okay, now, it could be 2 because we're lucky, but let's find out if we were really right. So let's copy this again. In fact, I might still be my, I don't know, anyway. Let's go into there. There we go. There we go. Right, we're back now to our real input, and just out of interest, no, actually, let's run it. Ooh, that's interesting. It's doing something, so it's looping round. We haven't got a value yet. Give it a couple of seconds. Ba-ba-da-ba-da. How are we doing for time? 8:53, perfect. Yes. 312. 312. Now, I think that was the answer, actually. Let's go here. Your puzzle answer was 312. Amazing. Now, that took a while, so let's just count. Yeah, let's just have a let count equals 0, counter plus plus. Oops. Oop. Ooh. Counter. Okay, let's run that again and just see how many times. So, it's obviously 1014 is the number of frequency changes, but how many frequency changes is it actually going to go through to result in the 312 here? Goodness me, 139,324. Okay. Anyway, that is that. I was also thinking of doing the next, the next puzzle. Where's my coffee? The next puzzle, but we're almost out of time. Closures for the win. Exactly. So Fred, well, yeah, you could do that actually. But what I've done is I've sort of, so Fred's asking here, it looks a little bit weird. Can you, what does the video preview look like? You can see the chat. By the way, folks, can you see your chat on the stream? I don't know what the stream do I know what the stream looks like? Where's my OBS here? Oh yeah, you can see it. Now what I need to do actually is I'll go into Streamlabs, and in the chat, this is behind the scenes, obviously. In the chat, hide message after 100 seconds. Let's put that up to 160 seconds or something. I don't know. Save changes. There we go. In the chat, now the chat messages to stay around a little bit longer. So Fred's saying he would expect more something. In fact, I've cut and paste that into just here so we can look at it. It does look a little bit weird, but what I've done, or what we have done together, let's go down here and close that. What we've done, if we have a look at line 5, we've actually resolved this lambda function and called it and put the result in scene. So scene is already the result of calling that. So that's why we can just pass frequency to that. So I hope that is, let's go down and delete that. I hope that has been useful. I hope that's been fun. I mean, this, again, we're not going to be doing, solving puzzles all the time. This was just a bit of a warm up, and it allowed me as well to figure out what the heck I'm doing streaming wise. So thank you very much for attending. It has far exceeded my hopes and expectations and everything for viewers. I really appreciate you joining. I hope you can join next time, same place next week, where we'll start hacking on something with the application programming model, Node.js version, of course, as we've now warmed ourselves up for JavaScript. And there's so much stuff to explore there. I'm really excited about that. And then maybe after the next one, or after that one, I've already warmed up these two folks in the Cloud Application Programming Model team. They're quite eager to come on and talk about this sort of stuff and share some insights. The reason I'm not doing it yet, because I haven't quite figured out how to get their video on this stream as well. I might just do a Skype thing or something with them and then screen capture it. I don't know. I need to figure that out. But anyway, thank you so much for watching and joining in, and most of all, thank you for interacting in the chat. That's what I really hope for. Is there anything else that we need to look at here? One awesome thing is that you're talking with each other as well and learning from each other as well, and I'm learning from you. So that's exactly what we want to do. So thank you. We've got 2 minutes to go, but I'm going to finish this stream now. And I'll see you next week. If I can figure out how to stop this stream, I'll see you next week. Thanks very much indeed. And have a great weekend, everybody.